Use Cauchy's integral formula to find integral over c e raised to z dz upon z plus 1 the whole raised to 4, where c is the circle, modulus of z equals 2. To obtain the singularity, we equate denominator to 0. We thus obtain z plus 1 equals 0 gives z equals negative 1 is the singularity, and z equals negative 1 lie inside the circle, modulus of z equals 2. By Cauchy's integral formula, we have f raised to n of a equals n factorial by 2 pi I integral over c f of z dz upon z minus a the whole raised to n plus 1. Here we have a equals negative 1, f of z is e raised to z, which is an analytic function, and we have n plus 1 equals 4. Therefore, n equals 3. Since e raised to z has derivative 2 times e raised to z, and f double dash of z is 2 square e raised to z, and f triple dash of z is 2 cube into e raised to z. In general, we have f raised to n z equals 2 raised to n e raised to 2z. When you give n equals 3, you obtain f raised to 3 of a, which is the third order derivative of f of z at z equals a, where a equals negative 1 is obtained as f triple dash of negative 1 equals 2 cube into e raised to negative 2, which can be written as 8 times e raised to negative 2. By using this equation, we can also evaluate f triple dash of minus 1 as 3 cube upon 2 pi I integral over c e raised to 2z dz upon z plus 1 the whole raised to 4 dz. By just giving n equals 3 wherever n appears and a equals negative 1 in equation 1, we obtain this expression. We can rewrite it as 3 by pi I integral over c e raised to 2z dz upon z plus 1 the whole raised to 4, because 3 factorial already contains 2 and 2 can be cancelled from numerator and denominator. We are asked to find out the value of integral over c e raised to 2z dz upon z plus 1 the whole raised to r, which will be 8 e raised to negative 2 into pi I upon 3. By just taking the reciprocal of this quantity and multiplying it to the LHS, you obtain the desired value of integral. You can also write it as integral over c e raised to 2z dz upon z plus 1 the whole raised to 4 equals 8 pi I upon 3 e square.